Welcome back everyone, and in this video we're going to go through the process of adding your own custom rig that you might have built manually or with a different rigging system and adding that to Hive rigs. So specifically we've had a lot of questions about how do I add something that I've built manually to a Hive rig. So for example, I've created a tail for something like a kangaroo or for a particular animal, or what do you want? Or if I've got a custom face rig that I built with another rigging system or even done by hand, how do I add that to Hive? How do I attach that to Hive? And how do I get that so that our FBX exporter that we have in Hive also works and exports our joint system as well? So we're going to go through that process, and I'm going to do it really quite simply and show you in two major steps. The first step is going to do it manually, and this is really good for getting yourself up and running really quickly and not worry about scripting. This is great for getting something tested quickly by your animators. The second process is how to attach that custom rig to Hive, and that's going to be done through build scripting. So what I'm going to do is I'm just going to create a small tail. Don't judge me on the artwork. Get that a bit. And then I'm going to just build that. So now we have our tail, right? And the next thing I want to do is now attach that. So to do it manually, and this is what we're going to do in code as well, is I'm just going to get the top joint, and I'm just going to go into Hive's joints chain. And you can see that's where the top spine joint is. So I'm just going to parent that to Sky. And now we have our tail parented to spine. And when we do the FBX exporter, it's going to get exported as well. Next thing I want to do is now constrain our control rig to Hive. Now, there's two ways of doing this. You can either constrain directly to the actual spine joint, which is a perfectly fine and normal way of doing things, or you can constrain to the actual control itself. The joints don't really come with much of a caveat, but the constraining to a control rig, to Hive's control rig, there is a major caveat. And that caveat is when you go between the build stages, like for example, going from the polish stage or the rig stage back to skeleton or guides, that Hive rig will get deleted. The other downside is you'll get with this approach is with the joints is that if you delete the spine or delete the whole Hive rig, you'll lose the spine joints for your custom rig. And that's why build scripting is one of the most important things you can do. If you want to do it manually, all you have to do is before you delete is just to unparent and remove the constraint, and you're good to go. So what I'm going to do is just as for the demonstration purposes, I am just going to select the hips anim control, and I'm just going to select the cog group, and I'm now just going to constrain. Now if we move it, we're good to go. So now we have something that we can just send to the animator to have a play around with. But now we want to build script that. So what this means is that when we go between the build stages like so, and now we go back, let's say just go rig, you'll see the tail is no longer attached, right? And this is because the rig is deleted and rebuilt, right, to accommodate for all your changes and build settings and so on. So we want to take that into account. You'll also notice that the joints are actually still parented. And that's because the joints of the rig is not deleted when you go between build stages. So you don't always have to detach, but it's also a good idea and as a safety measure to detach it between your build stages. So when you go into skeleton mode and just before the deformation the rig is updated, the joints are updated with your guide positions and so on. It's just to detach it and then reattach it in post-build. So that's what we're going to do now. So to add a build script, all you have to do is go into the rig settings and go down to build scripts and use your particular build script. But we don't have a build script for this particular situation, so let's write one. So I'm going to go into PyCharm, and now what we've got here is the spine component that we're going to attach to. What I'm going to do is add the build script folder that we have in the Zoo user preferences, and we're going to add that to PyCharm. Now, using this user preferences is the fastest way to prototype your build script, but it's not the only way. You can use your own custom zoo package, You can also use an environment variable to point to a folder that has your build scripts in it. I'm not going to go through that process at the moment because configuration of Zoo will be another video. At the bottom of my pie chart, I've added a folder to my project, which is going to be my ZooPrefs assets Hive. Inside the build script folder, I'm just going to go and say new Hive file. I'm just going to say attach custom table. Name it whatever you like. First thing I'm going to do is go into our technical documentation. And if we go down to the packages section category, down to the Zoo Hive category, and then you see this build scripting section right here. Go to the page, and then if you go down, you'll find an example code. Basically, this is just a stop for you to work with. So I'm just going to copy paste this into our code. I'm also going to create two variables, or three variables. So the tail joint name, and I'm pretty sure I did that. Tail control name, and I also want the tail joint parent name. So when we detach it, we'll be parenting it. And I'm going to go back to Hive, and I'm just going to copy paste the control group name. Make sure that's looks like that. I'm also going to go and copy paste the joint name of our tail. Make sure that's there. Control name is going to be the cog. There we go. Next thing is I'm going to change the path name. So I'm just going to call this attach custom table. Attach custom table. So the ID is really important. That's what gets registered into Hive. It has to be a unique identifier. So it has to be completely unique towards all build scripts that you add. And that's what gets registered into our template, into our build system registry. And that's how it does things like save your settings into the template. So it's really important that it's completely unique and it doesn't change. Once you've set it, you basically set in stone. That's pretty normal. So if you do make the changes to the ID, you make sure you update your templates and update your rigs to reflect that change. I'm just going to delete the pre-build and post-build guide methods. I'm also going to leave the pre-build, pre-deform build and the post-deform build because we're going to need that for the attachment of the joint and detachment. I'm going to delete the pre-rig build. I'm going to maintain the post-rig build because we're going to attach the control. The post-polish we're not going to need. We don't need the pre-delete guide layer. We do need to worry about the pre-deletion of the deformation layer inside Hive. We need to worry about the deletion of the rig layer, so that's the animation controls, and that's when you go to the when you go back from the rig mode or polish mode back to skeleton or the guide mode. So in that case, we want to detach our stuff. Deletion of the components, we absolutely do want to handle that, and that's because if the joints get deleted off the spine, or you just delete the whole rig, we want to be able to unparent our joints. So I'm just going to keep those methods as well. I'm going to go back to the top, and I'm going to create a couple methods. The first one is the attach joint. Now keep in mind what I'm going to do here is pretty basic. I'm not going to be, normally I wouldn't hard code everything. I would go through the properties, which I'll show you in a moment, just so you are aware of them and how to work with it. But I'll be here for like an hour or so writing every single line of code to make this reusable in every possible situation. So attach joint, detach joint, attaching the controls, detaching the controls. Now, what we want to be able to do is deal with the attachment of the joint first because it's probably the easiest. So the first thing we want to do is be able to get to the spine component. How do you access the spine component in a build script, or any component in a build script? The easiest way is to go and say self.rig, and then you can go to component and do it, and then pass in, like say, spine, and then you can pass in, second argument is the side. All right, that's one way of doing it. The other way of doing it is a really helper convenience function. It's just the getter function, which basically grabs the component by name like this. I prefer the first method because it allows me to use, it has more options in terms of how you actually manipulate those arguments. So for example, we're going to use properties and we're going to pass in the value of the property directly into here. So in this case, we're going to do properties driver component. And what we're going to do is say split that by comma, and I'm going to expand list. That's going to return. Now, keep in mind, I'm not doing safety handling here, so I highly advise you to do that, because everyone's going to break your build script pretty quickly. So we're going to create a new method called static properties method. This is an override of the base method, so this is going to return a list. And what we want to do is actually create a driver component property. There is one caveat with properties at this current stage, and it's rather limited. It doesn't allow you to pass in a driver instance and store that out. This is something that's limited for now, but it's going to happen at some point. So there's a very limited types you can support, which is a string, a file path, and a true false statement or bool. So what I can do is just go to the base class, which I'm just going to hold in control in PyCharm, and just click on the base class. And what you're going to do is get to here, scroll down where it says properties, and in the documentation, all you have to do is copy paste this snippet of code block, go back to your build script. Whoops, I didn't copy that properly. Paste it. So now you have these values. You just start filling it in. Now the layout is the location inside the layout of the UI. So for the name, I'm just going to call this the driver component. Now the name is not your UI name. The name is the name of, or the key within the dictionary that it stores. So it's like the ID for this property. The display name is what you see in the UI. So I'm just going to call this driver component. I'm just going to make this class because I need it. Now the value is going to, by default, be a comma separated list, spline m. Value, the type is going to be string. I'm just going to leave the layout as it is. I'm going to leave a tooltip just because for this demo, but I highly advise putting that in. And now we have the spline component. Go back to here, add a spline component in like that. Obviously, you want to type check that. Not type check it, but you want to make sure that you have the right length, that the spelling is correct, you format it correctly, that's all, but I'm not going to worry about that. Next thing is, that's just standard Python. What these properties are is just a key value pair. The key is the actual name of the property, the value is the actual value that you see here, right? So it's just this section here. And if you fill this in the UI, this gets saved into the template and then the rig, and then you'll get whatever value you get back. So I'm just going to say if on spline, just to do a simple safety handle. And I'm going to go and say, I'm going to make this a warning. Go missing component. And I need the logger. So I'm just going to go up the top here and just do a new import from the zoo logging module. I create a logger. Now, the reason why we have our own custom logger is so that all of our logging objects in instances for every single file gets added as a child of our root logger for ZooTools. So it's not the root logger of Python, it's the root logger of ZooTools. That means that when you are inside Py here and you say in the menu, developer debug logging, that activates debug logging for all your child loggers as well. You can also turn that on through an environment variable. So I'm just going to go back into PyCharm here. And the first thing I'm going to do is attach that joint. So we know that that's the joint name. I'm just going to do a quick safety check. Tail, joint name. That should do. Import our CMBS module, or minus CMBS module. And now what we can do is I'm just going to go and say, put that to Zappies and import that too. And fail joint name, set parent. to our spine dot form layer joint, and I know, and I'll show you how to get this information, is that the ID for the joint is by 0. You can also know, and you should probably be fully aware, that across all of Hive, there's not a single method that allows you to retrieve a node by its name. You might be going, then how do you access that node if you don't know its name? It's not the name of the node that you have to worry about, because the name of the node changes over time. For example, from project to project, or you have a gradual change over your production pipeline over a set of years. You want to eliminate as many possible scenarios where you have to refactor. So everything in Hive where we go and say, hey, I need to access a joint or a control or a guide, it's always done by its unique identifier. Those unique identifiers don't change. They may not exist because of, say, dynamically generated components like the FK chain or part of the spine, for example. So we have bind 00, but you can have as many of these as like bind 20, bind 20, 25. It could be bind 99. That's because we have options in the UI to change the joint count. So how do you get access to this ID? How do you know what IDs you've got? So if you go back into Maya and you select that particular spine joint, and you go into the attribute editor, down to the extra attributes for that joint, and you can see a attribute called ZooHive ID. That's the ID that never changes. The only time it changes is if we as developers make that change specifically in the actual code itself for the component. So now we can just copy paste that into the .joint on the form layer, because that's how you get access to the joints for each Hive layer. Now I will talk about how Hive layers work in another video, because it is a lengthy kind of explanation I need to go through, and it is really, really important, so it deserves its own video. Now I'm just going to import the Zappy module from ZooTools, so it's zoo libs Maya Zappy, and that's essentially parented. Now what we want to do is detach it. Now it's actually really straightforward. I am just going to do a quick safety. I'm just going to grab that, and I want to now just reparent it to the tail joint parent, which is going to be the top root of our tail, which also contains our controls. So that's basically the attachment and detachment. So if we now go back into Hive, or into Maya, and unparent that joint, and I'm going to reload ZooTools, and cross your fingers that we didn't make any kind of mistakes in that code. So if we go back into Hive Atlas UI, go into our configuration, go down to the build scripts, go attach custom tail. You can see now we have this option driver component where it has spline M. So if we change the component name, we can change it here to reflect that change. Now the reason why I'm not using underscores is because the user can specify as many underscores they want within the actual name itself. So the naming convention can change. Of course, you could still split by underscore and take, say, the very last value, but this is the more predictable way and safer way of dealing with that. There's other ways, which is using like a token, like a column, but I tend to use commas for this. So now if we go back to guides, and I'm just going to open up the script editor just make sure I didn't have any errors during that build. So the detach, so the detach joint should have been run, but we didn't run it, and that's because we didn't go down to these methods and add it. Silly me. So I'm just going to say self.detach in the detach joint for the post for properties. That's going to be for the pre-build, and we're going to say attach joint in the post the form build. That means that we're detaching the joints before we actually build any joints for Hive. It also means that it's before any changes to the actual joint transforms, because if we update the guides, we want to be reflecting the rotation order, the position and the orientation of those joints. So we're just detaching it just to be absolutely safe that it's not going to affect anything on our rig. And then all the changes that happen on the skeleton is going to apply, but it's not going to affect our rig. Then what we're going to do is then parent our tail to the spine after everything's being applied, which is great. So now if we go back into Maya, I'm just going to reload because I made those changes. Just give it a moment. Yeah, so we're now done. Back into the Hive. And if we go back in here, it should already be there, right? So it's already been saved, installed, and everything. So now we go back to skeleton. And hopefully no errors. So we have no errors, but we didn't get a... whoops, yes, that would... Yeah, so the problem here is that we actually misspelled this. So instead of being underscore spine, I mean S, it's uppercase, so that's wrong. We're going to make that changes there. But we can also just go into the first. Now if we go, so we just did the rebuild. Now you can see it's actually parented. So it's just a spelling mistake, my bad. Now we have it all parented. So every time we now do a build, those joints will get unparented first and then reparented after the fact. So now we want to deal with constraints of the actual controls. So this is actually pretty straightforward, but we're going to do the same thing that we do with the attached joints. So I'm going to create a new function here called find spine. Oops. And I'm just going to copy, paste that down, find spine, and spine, so that's fine. These, and I'm just going to say if spine is none, just to make that code a little bit nicer. And then attach control, we're just going to do the same thing. And to get access to our control, which we know is to be the hips. So if we go back into Hive here, and we just go to build of the rig. We select the Hive animation control, go into the attribute editor, extra attributes, and now we can just grab that particular attribute value. Go back into our build script, and now we can just grab access to that control. So we can go to rig layer, control, hips, and that's going to be our driver. The driven object is going to be name, the tail control name, and what I'm going to do quickly is just to check that. That way, if someone deletes the tail, it doesn't fail the build. But we still want to log something to state that, you know, we don't want to stop the whole build from happening. We do want to actually log something though, so missing control, tail control. So we have the hips. So the hips is always going to exist in this rig, this particular component. So I know that's always going to be the case. Now we wanted to create a constraint that constrains our control to the spine. Now I'm going to use a matrix constraint here. And now there's a limitation with the matrix constraints that we have in Hive, where it doesn't actually do space switching and it doesn't support joints. But it's a perfect situation where we don't require any of that. But we do need to maintain offset, but it comes with that capabilities as well. So simply put, I'm going to go to zappy.build constraint. The driver is going to be the hips. So if we have a look at this into our base function, we've got the driven, the drivers, and the constraint type. So I'm just going to pass that through. I'm going to change the constraint type to matrix. Now you're probably wondering what trace does. Trace stores metadata so we can retrieve that constraint at a later date. So that's why it's there. If you turn it off, it's not going to be trackable, and it's going to look like everything is going to look like a standard Maya constraint. But with a trace, it's going to store metadata on there, and it's going to do all the connections to the node network. That way, it's easy to delete, it's easy to query, and do anything else you want to do with it. It also means that if you're using, say, a constraint type of parent or scale, orient, and I think aim that I have support for, you can also add space switching on top. But I'm just going to use matrix, which doesn't support space switching in this case. And the next thing is I'm going to specify the drivers. So this is going to be driven object. And the drivers is going to be a list. Well, it's a dictionary. I gotta remember which one, what it is now. Targets is the key. So this is going to be our drivers. And this is going to be the tuple of tuples. Now you might be wondering why that's the case. The first value within the nested tuple is going to be the name of the enumeration field. So inside Maya, in any one of these controls, for example, if you come into the attribute, the channel blocks, you have these enumeration fields. So parent, world, and cog. We're going to be creating, we don't need any of these in this case, right? We're not creating a space switch, we're just creating a constraint. But I'm just going to use my code for that. So we're going to leave this name completely blank, which means it's not going to create anything for it. And then what I'm going to do is pass in our node. That's all we need. Now, there's more options here. For example, the attribute name, the type, the space node, and all kind of stuff. I will get into space switching at a later date and how to code all that. That's all we need to do there. What we now need to do is detaching. So now we need to detach it, and that means we need to get access to the constraint here and delete it. That is actually really, really straightforward. So we don't need to worry about exactly which constraint we're going to retrieve. We only have one constraint in this particular situation, and that constraint is trackable. So it's traced this way, like this. So we can access that very, very easily. So I'm just going to grab this bit of code here. And then what I'm going to do is say zappy.delete constraints, pass in the driven object, and that's going to do everything. What delete constraints does is it finds every single tracked constraint on that particular node. So in this case, that's going to be our tail cog group. And I know in this situation, we have no other constraints. Now we just reload. And now I'll go back into Hive. Go back to guides. I like going back to guides. You don't have to, you just go straight to scope. And now if we go back to rig and cross your fingers, I did everything right. No errors, that's a good sign. The joints are still there, and if we just grab this, and obviously I did something wrong. Yep, and I obviously didn't do it again. The same problem I did last time. I'm doing that. So I'm just going to detach control during the, attach control first during the post build stage. And now we can just detach during the pre-delete form. I'm not going to worry about that. But actually, let's do delete, detach the joints there. The delete rig layer, definitely detach the control. We can blindly do it across this method. Delete rig, do it there as well. And then for the delete the component, we only want to do it when, this is when you physically go in and say, I want to delete this particular component, right? And it's the same if you do it for the API. But the pre-delete components does not call this method because you already call this build method, so there's no need to call this, right? So, and the pre-delete rig doesn't call these two methods because you're already calling that build script anyway. So in this case, I'm actually going to say if component dot component type is equal to, I think it's the spine. Okay. So if you want to get the actual name of the type of that component is not the spine, and you don't need to do a type check by the is instance solution, right? So you just do the definition name that you have here, and you go spine IK. Oops. Be good if I actually copied it. And then what you can do is detach. Right? Now if I go back to Maya, do a reload, load up Hive again, go to skeleton, and what did I do wrong? I did make it a bit of a code issue, so a bit of a bug, my bad. So I'm just going to go into attach controls, and I'm going to do the same thing with the detach controls, and that is just to take this section here and just move that down. I'm going to do the same thing here. Just because I am passing a Zappy node into object exists, and sometimes, even though Zappy does support conversions of the actual class to a string by the node name, occasionally it won't quite work with CMDS, and so I prefer not doing it. But basically, I'm just going to use the module name, a module variable. Okay, so that still doesn't error. That's a good sign. Now I go to rig, doesn't error. That's a good sign. And now our tail is attached. And now if we go to guides, and if we take the spine, I'm just going to move the whole rig like here. All right, our tail doesn't move along. That's what we expect. That's what we want. Now if we go to rig, and if I did everything correct, I did everything correct. The tail stays where it is, still connected. You know, it's being parented, and now everything moves as we expect. So with this in mind, we're essentially done with our build script, but with our build script, it could be definitely improved. So for example, the properties section here, we can actually include all of this information as individual properties, and that can be easily done by just duplicating this out and do it that way. I'm not going to worry about that for now. I'm going to leave that to you to go even further and provide a better script. The next thing we can make as a property is the actual joint ID. So we can put that joint ID into here and do it that way. And that way we could make this work across any component. And the reason why that would work across any component is because we're not using any specific code for the spine. We're just looking up the joint ID. So there is a way to get the joint ID by the index, right? So there is a way to pass in a 0, and that's done by looking at the spine component. If we have a look at that base component for the spine, you can see we have the joint ID for number. So if you pass in the number, which is going to be like 0, it's going to return you the actual joint index. So if we look at the prefix, that's bind, right? But by doing it this way, by using this particular method, it might be more stable for the spine. But if you want it to work across any component, then specifying the actual ID for that component is going to be more ideal. And because you're passing in the name of the component, like its name and the side, it will work. You can specify, let's say in the UI here, instead of specifying the spine, you could say it's like the arm left, right? Now, it's not going to work in this situation because I've baked in the ID, but by having this as a property, for example, join ID, and I'm just going to bake that as a default, just for the sake of it, and I'm just going to put that next one, and instead of this, I can do that. And if we just reload, so now you have the driver component ID right there, right? So whether this will work or not off the top of my head is another story and a half. So if we grab the elbow component, for example, come down to the extra attributes, copy that, and we just make sure the name of the component is the same. Now, if we go back to, and if I didn't break anything, so now the joint is now attached to the elbow. The only thing that's kind of left is the display name is driver component where it's supposed to be joint ID, but that's, I'll leave that to you. The other thing is we still need the control ID, because if we go back to the attached controls, we're hard coding the hips, right? But now we can do that too. We can put that as a property and make it extend. So now you can create, add your own component and do whatever you want with it. But there's also other things you can improve, mostly about safety handling. So we've added things like the object exists as a base example, but you can continue this approach and make sure that, okay, that ID exists on that component, right? Because that's going to fail if you try to attach it to a component that doesn't have that ID. So that's really important. Now, that's kind of like all you really need, for something as simple as this. Now, every time you do a build, you'll have that build script that will just attach and detach and so on. Now, there's one big downside to build scripts and the way they are designed, is that a build script is initialized globally to the rig. It also means that you cannot have the same build script multiple times within the same process, in the same rig. So if you need to apply, say attach multiple build scripts that do things like, attach a custom rig, say, to the left and to the right, then you're not going to be able to use the exact same build script. But what you could do is create a subclass of the build script and create one for each one. The other way is to integrate that kind of behavior inside the UI as well. So that's it for this video, where we went for build scripting and the basics of it. You can go and do a lot more with build scripting, and this is something that we use quite often in Hive, in our own Zoo assets, and most of our templates have some form of build scripting. So this is a really good case of doing this, because it's one of our common questions that we keep getting. With that being said, I'll see you in the next video where we start diving into automating the rig updates.